through 20 today on CBA. And number 16 says if f of x equals 3 minus 2x and the graph g of x is a line perpendicular, what is the rate of change? Well, that word perpendicular is very important. With perpendicular, that means that my slope is an opposite reciprocal. So I need to find out what my slope is from the first one. The slope is the number with the x, so I'm going to take this 2 along with that negative sign and create that as my slope. But opposite reciprocal means that it has to be a fraction, so I'm going to make it into a fraction, which would be negative 2 over 1. And the opposite means I change my sign, so it goes from a negative to a positive. And a reciprocal means that I'm going to take my denominator and make it my numerator, and make my numerator my denominator. So I would end up with 1 over 2. Number 17 says, which of the following best represents the domain of the exponential function? So I need to know what the domain is. The domain is my x value. So I need to look to see if there's any place where it stops here. But it continues on forever to the left and it continues on forever to the right. So I can say that my domain, since it's my x, goes forever in the negative direction and forever in the positive direction. So it goes from negative infinity to positive infinity. Number 18 says a linear inequality in 2 variables is given below, and it gives us this equation. It says which graph represents the solution, and our graphs are actually on the next page. But since this is in standard form, let's go ahead and change it to slope-intercept form. So I'll rewrite the equation 5x plus 2y is greater than 4. To change it into slope-intercept form, y has to be by itself. So I get rid of my x's by subtracting, and I'm left with 2y is greater than negative 5x, that's now on this side, plus 4. Well, the y is by itself, but it's not down to 1, so I divide to get it to 1. So I divide by 2 on both sides and get y is greater than negative 5 over 2x plus 2. The thing that I need to pull out of here is that since it's greater than, that means it's a dotted line, because solid lines are greater than or equal to, or less than or equal to, so this is dotted, and it's above since the y is greater. The other thing that I need to make sure is that my slope is a negative, which means that the graph should go down from left to right. And that my y-intercept is 2. So if it does not have any of these qualities, it can be eliminated. So I'm going to make sure that I can look at my dotted and make sure that they're above first. F is dotted and above, so that's good. G is dotted, but it's below, so that one is eliminated. H is solid, so it is gone, and so is J. Now I just need to double check to make sure everything else matches up. My y-intercept is 2, which is what my y-intercept was here. It goes downward, and it goes down 1, 2, 3, 4, 5, and to the right 2, which matches my slope. So the answer is F. Number 19 says a linear inequality in 2 variables is shown below, and it again gives us a solution that we need to, or equation that we need to solve. So I'm going to start by doing that. So I end up with negative 4y is less than negative 12. The only thing I need to do is divide by the negative 4 to get the y by itself. When I divide by a negative, though, my sign splits. So I no longer have less than, I have greater than. And since negative 4 cancel out, I'm left with y. And negative 12 divided by negative 4 is 3. So again, I'm going to have a dotted line, and it's going to be above. If you take a look at the equation, though, there's not two variables. There's only one variable. And when there's only one variable, and it is a y, I end up with a horizontal line. So my line needs to go through where y is 3. Well, this goes through where y is 3, so we're good there. This goes through where y is 3. This does not, because here is y is 3, and it is x is 3. And then if I look at letter D on the back side, this one has where y is 3. And all of those lines that are remaining are horizontal. Now I need to check to see that it is dotted and it's above. This one is solid, which eliminates that. This one is dotted, but it's below, so it is eliminated. So the only answer choice that I'm left with is answer choice D. Last question of CVA is, what is the domain and range that represent the exponential function? And if you don't know anything else about exponential functions, it's shown here in the graph. Okay, so my domain again is my x values, and my range is my y. Well, my x's continue on forever in this direction because there's an arrow, and they continue on forever in this direction because there's an arrow. So my domain, you could say, goes from negative infinity to positive infinity. And the other way that I've told y'all about is the all real numbers. That's how you're going to see it a lot of times, the all real numbers. The range, it continues on forever, but if you look here, it flattens out, and it never quite reaches 0. So I can say that my y is greater than 0. It is not equal to 0 because it never touches there, but it is greater than it always. So I need to look to see for these two responses. Well, this one has my domain as y, so that can't be correct, and so does h. G says my domain is all real numbers, which is a solution, but my range is greater than or equal to 0 when it should be just greater than. So the only answer choice remaining is J, so x is all real numbers, which it is, and the y is greater than 0.